Who thought it was a good idea to put a fighter jet on a ramp and then launch it directly into the air with the help of a rocket booster? By the time the booster was exhausted and fell down, the aircraft was already moving at over 175 miles per hour. In less than 20 seconds, the aircraft plummeted into the ground. The US Air Force categorized this as a successful launch. The hard landing was expected because there was no pilot in the airplane. When the runway is not long enough or if an aircraft is overloaded, little rocket pods can help accelerate the aircraft in what's known as a rocket-assisted takeoff. To do this, one or more small rockets are attached on the sides of the fuselage and are activated by the pilot when needed for an extra boost. Now, it's one thing to help aircraft do a short takeoff from a short runway. It's a whole other thing when you want to take off from a zero-length runway, or in other words, from a stationary position directly into the air. But why the Americans, Germans, and Soviets all conducted experiments with zero-length aircraft launches starting in the 1950s, and why despite all their success, these programs were eventually abandoned, is not what you think. One of the nightmares for the US and its allies during the Cold War was that the Soviets not only had developed atomic bombs, but they also had a way to deliver them intercontinentally. This meant that an airfield in the US or Europe could now be completely destroyed in one hit, grounding the fighter fleet and making them unable to launch a retaliatory response. One idea to solve this problem was to put fighter jets on a ramp on the back of a truck, then launch them directly into the air with the help of a rocket booster, very much like launching a missile. Imagine being the first person to pilot a fighter jet that is strapped onto a rocket booster, mounted on a platform tilted up at 20 degrees and is about to be launched. There's a lot that could go wrong, which explains why the pilot is getting into the cockpit somewhat slowly. It's not hesitation, it's the weight of his massive balls. On January 5, 1954, with the airplane engines in full throttle prior to takeoff, the US Air Force launched an F-84G Thunderjet with the help of a rocket, but this time with a human pilot inside. This marked the first manned Zell launch in history. Bob Turner, who was the test pilot, said the G-forces during takeoff were similar to that felt when a plane is catapulted from an aircraft carrier. But 5 years earlier, in 1949, the US Air Force had launched a cruise missile in a similar manner. In fact, Zell was an adaptation of guided missile launching techniques for manned aircraft. This looks almost identical to Zell. The main difference is that this is not your typical airplane. This is MGM-1 Matador, the first operational surface-to-surface cruise missile designed and built by the United States. It had control surfaces very similar to an airplane. In fact, the US Air Force had given it the designation B-61, just like a bomber aircraft. A lot of the learnings from the MGM-1, as well as the other rocket-assisted missiles that came after it, were in turn used and adapted for the Zell program. For example, it was the exact same solid-fuel rocket booster from MGM-1 which was used for initial testing on the F-84. Once the rocket booster had exhausted its fuel, it was jettisoned in order to drop the extra weight, but also to reduce drag. One of the key benefits of the Zell program was that it enabled existing airplanes to be launched without a runway, as opposed to having to develop brand new airplanes that had such a capability. In addition to the F-84, the US Air Force also tried Zell with the F-100 Super Sabre. Testing showed that the F-100 was capable of a Zell launch while carrying both an external fuel tank and a single nuclear weapon, proving that the pilot could launch a retaliatory nuclear strike against the attacker. The Soviets conducted Zell experiments on MiG-19s, but not for the same reason as the US did. The Soviets' main interest in Zell was for point defense for critical targets, so a high-value target could be protected with a MiG-19 on standby, even if no airfields were nearby. In 1963, the German Air Force, Luftwaffe, also started performing Zell tests with the F-104 Starfighter in collaboration with Lockheed. The initial phases of testing happened in the US at Edwards Air Force Base. During this part of the testing, Lockheed used mock-ups made from concrete and steel instead of using actual aircraft. But why did they do that? A key component of the zero-length launch systems was the rocket booster. Of course, it had to be powerful enough to speed up the aircraft within 2 to 4 seconds. But it was critical that the rocket booster be aligned properly with the airplane. There is a reason that the booster is not in line with the fuselage, and also that it's not all the way in the back. The force generated by the rocket must be perfectly pointed toward the center of gravity of the aircraft. Otherwise, it would cause a pitch, roll, or yaw movement. Until the aircraft has gained enough speed, the pilot has no aerodynamic control due to low dynamic pressure, so he's completely at the mercy of the rocket alignment. These mock-ups had the same weight as well as the same center of gravity as the F-104, which allowed the initial testing to be completed at much lower costs without having to destroy actual aircraft. After the initial successful tests, the program moved to the Lechfeld Air Base in Germany, where a fixed launch platform was built for the subsequent flights. Zell may have enabled the launching of counterstrikes, but that only solved half of the problem. The aircraft still needed to land back somewhere. This is why, at the same time, another program was being developed in parallel, which in hindsight was a terrible idea. The Zero-Length Launch Matte Landing, or ZELMAL, was a program that investigated the possibility of a zero-length landing. This was to be accomplished with the help of an arresting cable, a tailhook, and an inflatable rubber mat for landing, where an airfield did not exist. We suppose it looked something like this. Only 2 manned landings were performed, and both times the pilot suffered back or neck injuries. Eventually, the Zell program was abandoned by Americans, Soviets, and Germans for a number of similar reasons. In the absence of a safe landing option, the pilot would have been forced to eject from the aircraft, resulting in the aircraft being destroyed. As was later tested in 1980, parts of the German Autobahn proved to be a feasible option for launching and landing of aircraft, even large cargo planes. But all that aside, the emergence of intercontinental ballistic missiles greatly reduced the necessity of aircraft for nuclear strike missions. Furthermore, the ultimate desire to have aircraft that could operate independently from a landing strip motivated the development of several VTOL and STOL aircraft, like the British Harrier and the Soviet Yak-38. In fact, only 1 year after the Germans cancelled their Zell program, the Harrier performed its first vertical takeoff in 1967.